Well, so here's the things I want to talk about. Stalking rate, by far, is the number one factor affecting how well cattle perform on a cornfield. So I want to spend quite a bit of time on stalking rate. I want to talk about the reason why stalking rate is so important. That's because the different parts of a corn plant vary really widely in their nutrient content. I want to talk some about grazing and modern farming. You know, one of the things I hear a lot, hey, Aaron, there's not nearly as much corn in the cornfield anymore, you know, today compared to 20 years ago. Can cows still, is there still any value in those corn stalks? So I want to talk about that, and then just talk about some things we need to do for animal performance, talk about supplementing, and then just some general management considerations. Okay, so first thing is to talk about these different parts of the corn plant. We've been out there and taken some measurements on the different parts of a corn plant and measuring their protein and energy content. And so what I've got listed here is the crude protein content of the grain, husk, leaf, cob, and stem, and also their TDN, that's total digestible nutrients. In human nutrition, we call that calories. For beef cows, we talk about TDN. If you own a feedlot, why you talk about NEM or NEGs? Okay, that's all the same thing. It's all a measure of how much energy is in it, and the higher the number, the more energy there is. Okay, so a bigger number, it's more digestible. The corn grain is really high quality. It's 90% TDN. Next in order of quality is the husks. They're about 60% TDN. Leaves are kind of intermediate. In fact, if you fed a mature cow, a dry, mature cow, corn leaves, that's the only thing she ate, she would maintain body weight. She would neither gain nor lose body weight. And then the cobs and the stems, they're poor quality. If that was the only thing a cow ate, why she would lose body weight and body condition. Okay. So, do you know, one of the things I think is important to note that it's like a lot of things in life, why the best parts, the grain and the husks and the leaves, well, the grain and the husks, let me limit it to that. The highest quality parts are the least common ones, right? We've got these measurements. I left the corn grain itself off this list, and because that varies a lot, and man, if 3% of the corn is left in the field, we think we're doing a terrible job of harvesting. At least that's what the people at John Deere tell me. Okay, they get pretty upset about that. And so we took these measurements. About 12% of all the weight that's out there in a cornfield is husks, which are the highest nutrient content. 27% is leaves, and then by far the biggest part is the stem. And I think, right, that's intuitive, and you could have told me that without me having to go to all the work of measuring that. But that's important, because what happens when you turn a cow out to a cornfield? What's the first thing she does? Yeah, she goes around and tries to find all the down ears, right? Of course, most of them are on the ends of the rows, and you can see them. They know that. That's part of their behavior too. Is you put them in a new pasture, even if there's no grain, they go around the outside, right? But you put them into a cornfield and they go around the outside. They know they're looking for those down ears. Once they get all the down ears, then what do they eat? Yeah. It's funny. I'm from Colorado, so you have to excuse my. I guess that's the terminology. I call them husks, and I know you guys call them shucks, but it's a hard habit to break. Yeah, that's not the only thing they eat, but primarily they eat husks at first when they're first in the cornfield. Then leaves, as the husks become, once they've eaten them, they can't, right? If she eats all the husks today, there's none for tomorrow. So over time, the amount of husks there become less available, and so she eats leaves. And if we leave her in the cornfield long enough, she will eat the stems and the cobs. But that's when we'll start to see her performance drop off. And that's the point I was trying to make here. If initially, because she's eating corn grain, it's a really high quality diet, but over time it declines, and we've measured that. What this shows is the digestibility of their diets. This was done with some steers, but when we first turned the cattle into the pasture, the quality is really high, but over time it decreases because they've already eaten the better parts. So the stocking rate has a really big effect on how quickly we go from the highest quality to the lowest quality. The more cattle there are per acre, the quicker they eat the higher quality parts, and the faster the decline in the availability of the nutrients that are out there. Okay? And we've talked about this project several times today, and I don't know, I guess we're going to give you your money's worth on this project. We've taken a lot of measurements, and I want to share them with you. And one is the difference in the performance of the cattle, because we have two different stocking rate treatments. And I want to just remind everybody of the treatments. One of the treatments is baling. We rake it up and bale it. We have a heavy grazing and a light grazing. Our light grazing treatment, we stock at 1 AUM per acre. Okay. Another way of saying the same thing is 30 grazing days per acre. Okay. Our heavy stocking rate is twice that, 2 AUMs per acre, or 60 grazing days per acre. Based on the average yield of this field, what we would recommend, like our typical recommended stocking rate on this field would be 1.5 AUMs, or 45 grazing days per acre. Okay, so our light stocking rate is less than what we recommend, and our heavy stocking rate is higher than what we recommend. Okay, and then we have a treatment where we don't take off any of the residue. We don't do anything to it. Okay, and I want to show you these are some of the numbers. This is the weight in pounds per acre on a dry matter basis of residue that we have in those. The way we measured this is we took they call it a quadrat. It's a square frame that was 1/2 meter square, and we set it down on the ground, and we get our clippers out and clip that 1/4 square meter. Then we sorted it by all the different plant parts and weighed it. Okay, it was a lot of work. We did that in 80 spots on this field, so 10 spots per treatment replication. And these weight, there's Umberto, I noticed, was saying about the field yields about just like 155 is the average yield on that field, and that rule of thumb is getting real close on there. We had almost 4 tons of residue per acre. Okay, so that's before we applied the treatments, and then after, we only had just over 1 ton per acre of residue left in the baling, and we did lose just a little. And I'll show. I've got it represented here. This is the change from pre to post grazing and also baling. How much we removed 71% of the residue with our baling treatment, 21% with our heavy stocking rate, and 18% with our light stocking rate. And then just for fun, the control. How come there's 4% loss there? Wind. Yeah, I wish I could quantify it, but I'm pretty sure most of that weight is in husks. In fact, I know it. We've sorted it by the plant parts, and I didn't bring it with me, but that's most of it. But also there's some decomposition. The before treatment measurements were taken in November. The after treatment measurements were in March, and most of the time it's too cold for anything to happen, but there is some natural breakdown of that residue. Okay, so that's all put together. But we had twice as many cows on the field for the same amount of time. That's how we got our stocking rates. The pasture size was the same. The number of grazing days was the same. The difference was the number of animals. We put twice as many in the heavy grazing as what we did in the light grazing treatment, and we only removed 3% difference amount of the residue. Okay. So I think that's an important thing to keep in mind is those cows really aren't removing a lot of the residue. And remind me to bring it up about manure when I'll talk about with that in 2. Okay, so even though this is how much residue we're removing, that's not how much we're removing totally from the field, because some of it comes back as manure. In fact, about half of that we would estimate, because they only digest about half of what they eat. Okay, so I'll come back to that. Okay, so we had twice as many cows in the same size paddock for the same amount of time. Are you expecting them to gain the same amount of body condition? No. Why not? Because if there's twice as many cows, there's just not as much husk to go around, right? So these cows, the heavy grazing cow, the heavy stocking rate cows had to start eating leaves and maybe even some stems and cobs, while the ones that had half as many, why they're still eating husks, 3 weeks into the 3 and 4 weeks into the study. Okay, and so we can see that the cows that were on the 2 AUMs per acre lost 4/10 of a condition, and the cows that were on the 1 AUM per acre maintained their body condition. There's 2 things I need to say on this slide. One is these were 2-year-old cows. Okay, so they were just getting ready to have their second calf. Their requirements are a little higher than a mature cow. So I'm going to come back to performance in a minute. And the other thing is, I don't know if you noticed, but the body weight goes the wrong way. And that's an artifact of how we had to do this research project. We don't have scales at the farm where this was done, so we have to truck them. The university's got a ranch at Whitman. It's about 150 miles to truck them, and we have some fill differences going on there. These cattle in the heavy stocking rate treatment are eating a poorer quality diet, and so they react differently to the fill. That's why the weights are wrong. It's the body condition. That's the best measurement of their performance on the field. Okay. Now I do want to go into some of these subsequent effects of our treatments, and we've talked about a lot of them already, and I don't mean to be redundant, but I just kind of want to hit the highlights. Like we talked about, we started this project in 2008. These are the corn yields in 2009. So the winter of 2008, 2009, we grazed and baled, and then in October, November, we got the yield numbers. Okay, we've been doing it we've got 5 years of data now, and this is the average across all those 5 years, and there's no difference in the yields across our treatments. Okay, we don't see any difference in yields. I want to talk some about soil water. I don't. That's something that's really important to us there. This farm is at Brule, quite a bit less rainfall, and it really makes a difference if we can conserve some of that soil moisture. That we know that the residue helps with infiltration. It helps to limit or reduce anyway evaporation, and we've been measuring the soil moisture on this field. I didn't bring any of the numbers to show you, but there is no difference. We don't see any difference in soil moisture these past 5 years now with our treatments. One thing I think is important to realize is that we're irrigating to make sure that we don't have that water isn't limiting on most of that field, and so I think that has an effect on our soil moisture numbers. But I think the bottom line is we're not seeing any difference in soil moisture according to our treatments. One thing that's pretty interesting on that field is just planting considerations. When we were designing the project, we kind of went round and round because, and maybe it'll make more sense if I go back to this. The rows go east and west, and so you could see if we were taking our planter and going along here, why first we'd be in this heavy grazing treatment, then we'd go through the baling, and then light grazing and no removal, and there's a big difference in the amount of residue that the planter would be going through just in one pass, right? And so I think there's good evidence. I mean, we know that it's really important to get our seed placement just exactly right. right? That the distance and depth is exactly right, so we get nice even emergence. And if we don't have that, then it can really affect the yield. And I think, so there are data that show, and especially the further east you go or the more productive your cornfield is, if we need to do something with that residue, or else we can start impacting yields. The university's got data. We've published some in our beef report that shows if there was a field where they removed about 25% of the residue and improved the yield, and that was their hypothesis as to why, was because it just made it where they were able to get in the field and had just better planting conditions, so they were able to get their seed placement right. And anyway, when we were designing this project, we worried about that. Would that sort of be confounding our data, because that on that same pass, we'd be going through all those different amounts of residue, but we don't see any differences, and so I think that's an important consideration, as I said. And I think there's instances if we have a really productive field where grazing could actually increase our yields just because we're able to do a better job during planting. Okay, what about volunteer corn? We know that we can reduce the amount of volunteer corn if we turn cows out there and have them eat some of that volunteer corn. It's not 100%, but it definitely reduces volunteer corn. What about nutrient removal? I don't mean to be redundant again and what Dr. Wortman was talking about, but grazing is a completely different situation than baling when we're talking about nutrient removal. If we bale up all that residue and haul it off the field to the feedlot, why, all the nutrients that are in that residue are removed from the field. Okay, but the same is not true with grazing. About half of what a cow eats, she's going to put right back onto the field. Okay, and technically, if we're using mature cows, by definition, all of the nitrogen they consume, they'll excrete. Okay, and I wish we could do something about distribution, because it's definitely not even. And if there's a bit of a windbreak on that field, of course, that's where all the manure piles up, or near the water, right? Wherever they spend most of their time, that's where the manure gets deposited. So I'm not trying to oversell this one, but also at the same time, we need to remember it's a completely different situation from baling. Okay, and we just need to keep that in mind. We're not losing all those nutrients. Yeah, no, that's one thing that didn't come up today. Plant diseases. We know some plant diseases are overwinter in the residue, and if we can reduce the residue, we can potentially reduce our disease pressure. That's something that we got started measuring out there at Brule, and I hope that we can kind of continue that. That's one where we'd like to try to expand our efforts. So, and then Tim and Umberto already talked about soil quality. And Tim did mention some about that. There's a field at the ARDC, so it's near Meade, Nebraska, where they had the treatments. It was fall grazing, and then they took the cattle that were. What they did is they just moved the cattle to a new section of that field, a new part of that field, and so part of the field gets fall grazed, part gets spring grazed, and the timing is so they put the cattle on as soon as they can in the fall, as soon as it's harvested, and then about the middle of February they move them to the spring grazed part, and they stay there just as long as they can. And they assure me that it's muddy every year, and the cattle put a lot of tracks into it. Okay, and Tim showed you the compaction numbers, that there's basically no difference in the treatments, and these are the soybean yield. So it's in a corn-soybean rotation. Okay, so if you're in a corn-soybean rotation, the crop following corn stalk grazing is soybeans, and this is that's a statistical difference. That the fall graze, you actually increase the soybean yield by 2 bushels compared to leaving it ungrazed. And I think I wish it were a continuous corn, because I think it would be no difference. Okay, instead of an advantage, because I think that's sort of that's more a function of soil temperature and the fact that we have soybeans. Okay, that they're more sensitive to photoperiod, and I think what happens is if you get a warmer soil temperature, in essence you're having a longer growing season. Okay, and so, but anyway, I just think I always like to show these results whenever people talk about compaction, because I think that's one reason why some people are, well, whenever I meet someone who's reluctant to graze their corn field is because they're worried about compaction. And I think these are some of the best data we have to refute that, along with our data at Brule. But I think we need to keep it in perspective. If we're going to really try to manage compaction, why we need to start talking about limited traffic and all those kinds of things, that they're going to have a lot bigger impact than a few cows that are out there walking on the cornfield. And I'll never forget it. It was one of the first times I was given this talk. I was saying that, oh yeah, you don't have to worry about compaction with the cows, and an old guy in the back gets up and he just yells out, that's a lie. I can show you exactly where the water tank was every year by looking at my yield monitor map. And I guess what was I going to say? If that's what he believes, I think that's, and I think it may be true that there are some instances where, yeah, you can really get some compaction where the cattle really congregate, like at a water tank. But to me, the thing to keep in mind is, let's keep that in perspective. I mean, it's a really small fraction of your field, and if it's really that big of a deal, if it's a possibility to to locate the water in a place that would put it on a pivot corner or someplace where it's not going to have as big of an impact. And then everyone's, well, yeah, Aaron, that's not where my well isn't on the corner. Yeah, okay. But I think that's something we can manage. All right. Okay. Tim talked about this nav guide. He showed one for baling corn residue. We've got a companion one for grazing. What we've tried to do is we've got an Excel spreadsheet that goes along with it, and we've made a spot where you can put in, okay, what are the costs and what are the benefits. And so for all these things we talk about, nutrients and soil moisture and yield and volunteer corn, all those things, we put those in a spreadsheet so to help you manage the costs and just look at the bottom line. And I think it's a pretty helpful tool, and so I just wanted to bring it to your attention. You can find it on our website, and if you just Google grazing corn stalks, you'll find it, and then you click on this button and it opens up the Excel spreadsheet so you can punch in your numbers and do an assessment for yourselves. Okay, I want to come back to this idea of stocking rate. I just realized I've taken more time than I thought I was going to. Usually I like to blame it on everyone asking too many questions, but so far no one's asking any questions, so I don't have that excuse. Let me just hurry through, because I think this is kind of important. Stocking rate's really important, and we know that there's about 16 pounds of leaf and husk per bushel of corn grain that's produced, and then once you know that, all you have to do is the math to figure out what your stocking rate ought to be. You can do it by hand, and if you want to, I'll walk you through the numbers. But we came up with a better way. We have this Excel spreadsheet we call the corn stock grazing calculator, and it does all the math for you. So you just punch in the numbers, and it'll do the calculations. If you go, this is our website, beef.unl.edu. Right here is the corn stock grazing calculator. If you just click on that, it opens it up. And I know no one can read this, but I wanted to show you what it's like. It's got a spot where you tell the spreadsheet what your field yielded and how many cattle you have, and it will tell you how many days to stay on that field. Okay. So it's pretty handy. If you're interested, let me know, and if you have questions, you can call me, and I'll walk you through it while you're on the phone.
Does it matter how old or how mature the cows are or anything like that?
What matters is their body weight.
Okay.
So how much a cow eats is a function of her size. So you put that in as well. Yeah, and teeth. Yeah. That's right. I'm not a dentist. So, that, you're on your own on that one. Okay, what about supplementation, weather? Oh, and I want to talk about, everybody asks me, hey, Aaron, now that I've got, Roundup Ready corn and triple stack, and I appreciate what Umberto said. I thought that was kind of, he's like, well, I'm not an agronomist, but I like to work across the line so I can look at the whole system. Well, I'm not a plant reader, but I like to at least talk about, I should learn all their terms. Those guys are pretty smart. Maybe people will think I'm smart if I can say all their terms. So I want to talk about that just really quick. Okay. Got to make it fast. If you feed cows, okay, if you stock according to the corn stock grazing calculator, and just roughly, 45 grazing days per acre on a irrigated cornfield is about right. Okay, we've already talked about this. The higher the yield, the more residue there's going to be, right? So the longer you can stay out there. That's what the corn stock grazing calculator does. That's why it's nice. But roughly 45 grazing days per acre. Okay, then if you feed supplement to a cow, if you feed her protein supplement when you're stocked at 45 grazing days per acre, she will increase body weight. If you don't feed her supplement, she maintains. All right? Okay. But is there any economic advantage? Yes, there's a performance advantage. Is there an economic? Do you get your money back out of that cow if you feed her protein supplement when stocking rate's appropriate? How could you do that? What could be the potential return? It'd have to be either increased pregnancy rates or increased calf weight, right? Well, we've got 2 different studies and close to 10 years worth of data that show there is no economic return to feeding protein supplement to cows on a cornfield if the stocking rate is appropriate. Okay, if your stocking rate's too high, then you will see an economic advantage. But if you set your stocking rate appropriately, I guess, so what I'm trying, the position I'm maintaining is that you're money ahead to move cows to a new cornfield rather than stay there too long and feed her protein supplement. Okay. I know some people say, well, Aaron, you make it sound like there's open cornfields all over the place. And it's true, the further east you get, the more there are. And, where I am at North Platte, good luck trying to find a cornfield. But as a general rule, there is no economic advantage to feeding protein supplement to cows on a cornfield during the winter if you have the stocking rate appropriate. Okay, and I can show you. We'll go through the data sometime if you want. Oh, we were talking about weather. Tyler already talked about it. I don't mean to belabor it, but if you got to have a backup plan because when it snows, you got to do something, right? One of the things I've noticed is it tends to be, most people tend to overreact to snow. They're too quick to go out and feed the cows. A cow can easily move 6 inches of powder, snow. She can dig through that and keep grazing just fine. Okay, where we have the problem is when we get ice or when that snow crusts. Then she can't get through it. Okay, and we need to remember the difference between supplement and substitute. Okay, if we think we can just feed a couple of pounds of cake or some kind of feed to cows when there's ice or crusted snow on that cornfield, then that's not going to work. Okay, we got to replace their whole diet. But again, I think I'm just going to cut to the chase. I think snow risk is oftentimes overestimated, but ice risk isn't. Oh, I'm going to go through. I love that this was fun. When I first came to Nebraska, here we were January 5th on this cornfield, and it was like, I should have written it down. I can't remember what the temperature was now. It was almost 70 degrees. Okay? And then just the next year, same cornfield, and it was 10 below zero. Okay, I mean, yeah. So right, it makes a really big difference. I don't know if this is valuable to spend time talking about or not. Usually, so if cows get too much corn grain, it can cause a problem, and usually the problem is from spills. And yeah, I know you guys can all tell me the story about it's never the combine operator's fault. It's always whoever's driving the grain cart, right? And can you tell that I've never been they never let me drive the combine. I'm always the one driving the grain cart, or whomever that we hired to drive the truck or whatever. Okay, so spills, that's a big deal. But down corn's usually not, especially we don't have guest rows anymore with GPS guidance. The combines are a lot more efficient. It's usually not an issue. And then, I kept saying that until 2012 when, I don't know what the wind was here. It was October 17th, I think, was the day. At our farm there at Brule, we had 70-mile-an-hour winds, and it blew down all the corn, and we had all kinds of corn. And I think the further east you got, the less there was, but further west it was a big issue. And then, okay, now we're talking about a problem, and usually about the only solution is cross fencing. If there's a lot of grain down there, so bicarbonate helps. It does help to kind of adapt them, but really cross fencing is about the best solution. And I know nobody likes to hear that because it's a lot of work. We have a study where the university was doing some work. They had some BT corn, and it was the exact same hybrid that didn't have the BT gene in it. They were doing some work for one of the seed corn companies, and they did a research project. They turned cattle out and had replications and controls, and they got the exact same performance. These were steer calves. They got the exact same performance on the BT hybrid. Well, it was the same hybrid, the BT gene and the non-BT, exact same performance. And we can't measure a difference between genetically modified corn and non-genetically modified corn. I know it's not a deal anymore with refuge in a bag, but it used to be, when we used to have to plant refuge acres, the cows could tell you where the refuge acres are. They'll eat the refuge acres better than they will we can't measure it. I don't know why. I can't explain it. We can't measure any difference in the laboratory or in animal performance, but they do have a preference for it, and we know that happens. But let's not make a big deal out of it. Let's not overblow it. And to me, this is a research project that shows that corn stalks is still a really good resource for cows in the wintertime. And I just want to compare it. WR stands for winter range, and the 2 is how many pounds of cake we fed them. So it's protein supplement, 30% crude protein. We fed them 2 pounds per day. Compared that to cows on corn stalks that were not getting any protein supplement at all, but our stocking rate was 45 grazing days per acre. Okay, there was no difference in the body condition score of the cows, and no difference in their body weight, no difference in the calf weaning weight or their pregnancy rates. Okay, so cows on a cornfield with no protein supplement do just as well as cows on winter range getting 2 pounds of cake. That's even though there's not as much corn in the field today as what there was 20 years ago. All right, so let me just sum up. We have a lot of residue in the state. In fact, if we put every cow on the cornfield in the wintertime, we couldn't graze up all the corn stalks in the state of Nebraska. Can you believe that? Stocking rate's the single most important factor. If we get their stocking rate right, our cows can maintain body weight, body condition without protein supplement. If it's too high, if our stocking rate's too high, then we'll see decreased performance. Okay, so that's really important. And the reason why stocking rate is so important is because the nutrient content of the different parts of the corn plant, they vary so widely. We don't have to worry about all the things the plant breeders are doing. It's still a good resource, and we can get comparable animal performance as winter range. Okay. Does anybody have any questions?